just to introduce ourselves, I'm Alan Lind. I work for Critical Start. I'm a 1989 graduate of West Point. I was in the Army until about 97, and then I left to join the FBI and worked there on cyber squad doing computer hacking investigations, mostly criminal enterprises and nation state. Following that, I retired in March of 2019, worked for Blue Cross Blue Shield for about a year, and then I joined over here at Critical Start in March 2020.
Yeah, my name's Chase Arneman. I'm a senior adversarial engineer over here on our red team. Been doing hacking for 2 years at Critical Start, and then a number of other just IT and security jobs before that. I've also got multiple CVEs and exploits, and I write malware for our team in general.
Since everybody is here, hopefully to learn about security for SCADA, why should you care about security for your SCADA system? Honestly, in the last year alone, there has been a 2,000% increase in attacks. So saying it grew drastically in the last 2 years is an understatement. If you look at the IBM X-Force report, you're going to see it's just exploded. And partly that's a result of the systems themselves becoming more integrated and becoming more pervasive. When you're talking about OT SCADA, it can be everything from controlling the HVAC in your building to controlling the robots on your production line to controlling your infrastructure like your pipelines, your gas lines. There's pretty much no place in manufacturing where you're not using a SCADA at this point, an OT system. So the attackers go where the victims are. And as these become a larger, more critical component of your system, if you're a pharmacy and you're producing drugs and you need the robot to be doing it in a clean room, hey, what better way of getting ransomware and demanding money from you than stopping your systems and making them not work so they can get that quick bang for the buck? They're also getting bolder in what they're doing. So initially what we would see is people just taking over the actual system itself. Now we're seeing, again, ransomware that locks it. We're seeing other attacks. We're seeing effectively that because people can be remote and do this, they don't think they're going to get caught or get captured or found out. So that emboldens them. And there's not been a lot of prosecutions along these lines when these are there. So people aren't reporting them. People aren't getting prosecuted for them. All that emboldens the attacker. So what are the largest threats? Right now, the largest threats are really two groups. The first group is the advanced persistent threat. That might be a nation state. Those adversaries are targeting these systems for a variety of reasons. One is to cause disruption for the infrastructure so that, again, and you'll hear this in the example, if they can disrupt pipelines so that gas can't get to military vehicles, that's a win for them. If they can disrupt production of new fighter jets, that's a win for them. The way those threats are materializing, again, we're seeing commodity ransomware becoming a real issue on the OT SCADA side as opposed to just the IT side now. We're also seeing the same attacks that we've always seen: phishing, password spraying, all of the normal attacks where you're basically going after a human being or going after weak security measures, the virtual private networks. And in this space, a lot of what we're seeing right now is, again, attacks against the vendor, because you may have it secure on your end at your place of business, but if you attack the vendor, then they can get usually into the system from there, because the vendor usually has some way of updating the software, applying patches, keeping things up to date, or helping you monitor the network and helping you do repairs to the network. And then again, like I said, the escalating tensions are really causing cyber to become a forefront. I mean, there's a U.S. Military Cyber Command, at this point. There's foreign governments are doing the same thing. It's very asymmetric. You can invest very little for a large return.
Sure. So what are some of the common mistakes that we see when we pen test SCADA or we do segmentation testing or test against SCADA environments in general? So first one obviously is that segmentation is not done correctly. So oftentimes SCADA, people have problems securing it, rather because it's old technology or it's integrated strangely. So instead they segment everything they can around it, just like you would segment your internal network from the internet. So we see issues with this where things aren't correctly segmented, meaning they can touch the same internal network, or we see that things are replicated over so that the same level of access can then be used in the SCADA environment. Another thing we see is that there's no detection capabilities inside their SCADA network. So they segmented it off and then they assume it's safe, right? But they're not actually monitoring it or doing anything to see if something is wrong. So then when someone gets in their SCADA environment, they have no way to know and they can live there for a long time. We also see issues because the SCADA systems are hard to learn and it takes time for an attacker to learn it. People assume that the attackers aren't going to know it, right? So, but there's always someone out there who's going to spend the time to learn the system and who'll have enough money to buy it in order to test against it. We have also seen SCADA systems directly connected to the internet, and that's always an absolute nightmare. And then, once again, similar to the difficulty of learning, people are reliant on the fact that the protocols are proprietary or very obscure, and so they assume that you're not going to know how to attack it because you've never seen it. But once again, people will buy these SCADA devices and set them up correctly in order to test against it to know exactly what they need to do to attack you.
So we're going to go through a couple of case studies which are going to help highlight some of these issues here. So this is one that's again, an advanced persistent threat. Unfortunately, this one is not public knowledge, so I'm going to have to keep some of the details vague. But in 2005, what really happened was that, and you love hearing this from people because if you're in IT, you hear this all the time, something funny is happening with our system, right? Which can mean any of a million different things. So in this case, it was a utility, and it was actually the workmen on the utility, not the people who were running the SCADA controls for it, that noticed some what they called funny behavior at the various junctures where this utility. I mean, it's not going to make sense unless I say it was a water utility. So the people working on the actual pipelines, the people actually getting the delivery of the water, were noticing just strange behaviors. As a result, they basically first thought it might be mechanical trouble. They went to that. Then they thought it might be some trouble with, perhaps it was the actual machinery itself. That was the SCADA machinery that hooked into it, and there was a problem there. And after they'd eliminated that, then and only then they go back and start looking at the actual control system for the SCADA. When they did, they discovered that one of the people who were in charge of that utility had a desktop that was directly connected to the SCADA controls. There was no segmentation, no authentication, nothing. So as soon as you were logged in as that user and were on that computer, which any hacker could have done, which security was not really that great on this particular system, and they used a fairly common exploit to gain control of it, it gave you direct access. So they could actually pull up the SCADA control screens, it's basically by clicking on an icon on the screen, for lack of a better term, and they were right in the application. It brought up a GUI. They were able to see everything about the system, and they were basically experimenting, seeing what the different controls would do as they increased water pressure, decreased water pressure. rerouted the piping from place to place, turned pipes on, turned pipes off. In this particular case, worked out in the favor of the city and the utility that this was going on, in that nothing actually got damaged. So there was no actual damage. None of the pipes got hurt. None of the pumps got hurt. But you know, again, if we're in time of conflict, absolutely could have been crucial, especially if this is a larger place than where it was. And you can imagine, if it's in a port where we're trying to get soldiers out on a boat or something like that, or New York City, and you've turned off all the water, you're going to have mass panic, you're going to have mass injuries, you're going to have people getting dehydration. So this is, something that could have caused serious impact. In this particular case, it didn't. We were able to very rapidly identify from the computer who it was coming in, watch the traffic, and then add extra security controls so that it didn't occur again. The other one that I'd like to talk about is the scenario we actually see more often, at least right now, which is trusted insider threat. And in this particular case, what happened was that Jesse McGraw, who was a security guard at the W.B. Carell Clinic here in Dallas, which is a sports medicine center and also a physical therapy center. They do operations there. Was a member of his own little hacking group. I don't want to call it script kiddies, but if you think of a 4chan group that's being called his, he was Ghost Exodus. It was the electronic part of the electronic leader of the Electronic Tribulation Army. And they were in a DDoS war with another set of group of guys from 4chan. So they were basically hacking each other back and forth. Jesse was the night guard at the clinic, so he had physical access everywhere, including the closet where the HVAC system sat. There was really no reason for him to have that access. The security company just insisted that they have physical access to every room in the building, and the hospital granted it to them. Jesse's kind of a weird case in that he had actually been fired from multiple places before for messing with their computer systems as a guard, but nobody had ever actually put it down on paper, and nobody was relaying that in an HR perspective. So the clinic had no idea that it was a security risk. The company he was currently working for had no idea he was a security risk. And he basically had unfettered access at night when nobody else was around to this closet where the server was that ran their HVAC. So on multiple occasions, they had the HVAC go out. And Texas, this was in leading up to July, it was June. There was 100-degree plus weather out there. The HVAC had gone out. Each time they called the vendor who was in charge of the system, the vendor had fixed it. They just assumed it was software defects, software glitches, maybe something brought on by high heat, whatever. They brought it back under control. They didn't have any injuries. They didn't have any surgeries that had to be rescheduled or anything like that. But what Jesse was doing was, once you got physical access, he was basically, and this is the day when you still had CDs, he basically inserted, booted from the CD, took over the computer, recovered passwords, gained control of the device, and then once he did that, he put on TeamViewer so he could actually access it remotely, control it remotely. But again, once he had access to the machine, no controls past that. You just had to click on the application and you had to put in the extra passwords to get to the SCADA software. So as long as you were logged into Windows, you had it. I mean, now they did have it so there was only an admin on the account. There weren't multiple accounts on this machine. So they had some RBAC controls. But again, once you had the password from using the CD to boot, it was over. You had complete control. They did have logging on the system, which is a good thing. So they could see when somebody was using the SCADA system. They could see times, what accounts it was. Now, again, you couldn't tie in necessarily accounts except for the fact that we had physical access. And there were also cameras inside the hospital that did show him entering in. Jesse, if you want to Google it, you can actually see him. The reason he got caught, to be honest about it, is he was trying to show off to his buddies. So if you look for a video on Google or on YouTube and you Google it, you will find Ghost Exodus hacking. He actually goes in and shows off that he's doing it. A white hat saw the video, saw that it was looked like it was really a system, reported that to the FBI, and then the FBI was able to use that to track him down and arrest him. He did do 5 years in jail for doing this. But again, you can see all the potential problems on this HVAC. So, like, for example, all the instruments that were sterilized, they all had to be kept in a temperature and climate-controlled room. He didn't, but he could have been turning that on and off. In the surgeries, there's overpressurization. Again, he didn't turn that particular device off, but he could have been. The hospital estimated that if he had done any of those things, they would have had to invoke their emergency backup plan, which is basically move all the patients to another facility, reschedule all the surgeries, etc. And it would have cost them hundreds of thousands of dollars in order to deal with this threat. Again, fortunately, this was caught prior to it actually happening and was able to be stopped, with the exception of those couple of times he turned off the HVAC system during the 100-degree weather. And even those times, the vendor was able to regain control and reset to a normal state of affairs. Once you had the team viewer on, had they not been doing that, he would have been just escalating. We actually stopped him on July 1st, and he had put out another video that said he considered July 4th Devil's Day, very patriotic young gentleman, and that he was going to do his mass DDoS and take everything down on July 4th. So this was literally stopped days before it was going to actually become a critical issue.
Yeah, so with those examples, we really need to make sure that you prepare for the worst, right? Because no security is perfect at all. Eventually, somebody is going to spend way too much time and money replicating your environment if they want to get in. So what can we do about that? We can segment, right? So one of the biggest things to do is segment SCADA and OT and away from your main network. Because when your accounting department gets phished, you don't want them to easily be able to pivot into your SCADA network. Now, you also want to patch whatever you can. So yes, there are a lot of older technology or specialized technology that's not up to date, and there's nothing you can do about that. But what you can patch, you absolutely should. And what you can't patch, you need to continue to segment. So you can't just segment the whole outside. You should also segment internally. So if you have a certain device that can't be updated and is really just really old but really critical, you can segment that inside of your SCADA network away from the rest of it. That way, if someone does get inside, your more important stuff is even harder to get to. You'd also baseline your traffic to look for anomalies. So just like you would in your normal environment, you need to make sure that you spot what's wrong. So if you always have a certain amount of traffic going between devices and all of a sudden you see new stuff, you want to be alerted on that so that you can tell when you've eventually been breached. And lastly, you really want to train your staff. So just like that second example where it was an insider threat, or even if you look at Tesla was recently, one of their employees was offered $1 million to ransomware one of their factories. right? You want to make sure that those users report that to you, right? Because you want to make sure that you're aware of it when they're reached out to, or when they're breached, or when they click a link, because you don't want to punish them. You want to just know. That way you can react and respond to it. So continuing from there, how can you plan for it?
Thank you, Chase. Your incident response plan for SCADA is not going to be that different than your incident response plan for IT. And you would put hopefully an incident response plan in place for IT. You've got to do the same thing for your OT. The main differences that you're going to get when you're doing this is, when you're doing the preparation phase, is developing that access control list, which you would do for IT as well, but here you really want to restrict the access a lot more. Generally, people on the IT side, there may be individual applications that are protected, or there may be different levels within there where you have different access to the database, read, write, etc. You've really got to concentrate on doing that at a higher level for this. You also want to make sure you've got a watchable map of all equipment and connectivity. So we've been out to places, for example, that have HVAC systems in place, or and I'd call it more than that. It's really a data center that had it's not just an HVAC. It's the humidity. It's every aspect of that: the water, cooling, the electric, the fluctuations of power, the voltages being checked, everything that was running the data center, right? And that system, that data center, was unfortunately also connected to the main IT systems. Now, there was network separation via a VLAN, but that wasn't actually sufficient to stop somebody from being able to cross over if they were in the network and had control over the IT network. So they hadn't planned on the segmentation. They hadn't really looked through it. But all the preparation is, again, going to come back to what equipment do we have, what's the connectivity, what's the different ways we can get connectivity, is it connected to the wireless network as well, is it not connected to the wireless network, does it have radio access, because your engineers need to be able to, to pipeline that stretches hundreds of miles, they need to be able to take control over the different points. All of those things have to be part of the preparation as opposed to the reaction. And then in the identification side, you're going to have to add one more step to that, which is when you're trying to make identification of, is this really an event or not? You do that in a normal IT event, but here you're going to have to add, is this, like they did actually at the water facility, water utility, was this an engineering or hardware mistake? Is this something that's just caused by actually the physical device? Has the pump worn out? Or is it something that's actually a security incident where somebody has gotten in? Containment is again very similar with a little bit of a different flair to it, kind of a different flavor. If your machine is hacked, if you have a VM that's hacked, most likely the first thing you're going to do is disconnect it from the network. The same thing here. Get the device off network. The difference here being taking a device off network, let's say it's your email server or something, isn't possibly going to put somebody's life, safety, and security at risk. So you're going to have to know beforehand on the system what can we take offline and what that effect is going to be on the system. It doesn't mean that we're not going to be getting, gas is not going to be flowing. What's the business impact? And again, those should be done for IT as well, but here there's a much higher risk correlation. If somebody can't get email, that's annoying. If somebody can't get water, that's life-threatening. So understand the consequences of taking something off network. And then the investigation on this, again, very similar to normal. I mean, you're going to be doing forensics on these devices too, but since a lot of these are proprietary, you're going to need to have subject matter experts in these devices, either on call or that that are part of your staff. And the other thing is, the same as you would normally be conducting open source intelligence to see if there's a vulnerability in, let's just say, your Citrix environment. If you were looking at something that had happened there, you're going to want to be doing that same kind of OS intelligence, open source intelligence, for the SCADA systems, and those aren't as ready to find. So you're going to have to know where to be looking for that beforehand. Eradication is going to be the same. Recovery really is the same. Get it back online, and then lessons learned. Once again, this is the same system that you're going to use. I mean, it's the standard IT response system, IT plan, just tailored for your OT systems. Finally, SCADA Security and OT Security is something that usually gets bolted on afterwards. So what's really going to help and make sure that you have a effective and good SCADA security, OT security, is to put it in beforehand. IT, typically you're talking 3 to 5 years for replacement of systems, upgrading of systems, etc. So you're in a much faster pace. SCADA, OT, that could be a 15-year to 20-year life cycle for the systems. So if you're not planning for this for the long term, you're going to have a much larger impact over time. And again, it basically comes back to when you're making the business case for putting security in as you're planning this deployment, it comes back to, what's the potential damage? What's the benefit you're going to reap from having this in there? How much is it going to cost? And like any time you're doing a risk assessment or business impact assessment, just what's this going to do to us? I mean, if, again, you're a water utility and we can't deliver water for 3 days, how bad is that going to look for us, public relations? How much is that going to cost us? What are we going to have to fall back on? Are we going to have to get trucks and be delivering water to all of our customers? Is this going to, what's the impact going to be? Is this a gas pipeline? Is this, again, a production system where you're making medications and you're not going to be able to deliver those medications if these aren't working? Are we not going to be able to produce cars for, 3, 4, 5 days? So, that business impact analysis shouldn't be hard to do. And again, it shouldn't be hard to sell this to somebody. If you're going to put in millions of dollars in SCADA equipment, OT equipment, to add the overhead for security to reduce those risks, should be straightforward sale to your C-suite.